In question number 9, Ryan is shooting a .10 kilogram arrow horizontally from a height of 1.5 meters. He pulled back with 298 newtons, and he pulled the arrow back 0.65 meters before releasing. How fast is the arrow going when it leaves the bow, and how far does it go before hitting the ground? Now, as far as the test is concerned, we're really only concerned with the first question, but I will answer both of these questions. So the first question we're asking is, how fast is the arrow leaving his bow? Well, to understand this, we have to go back to that concept that if we change our potential energy, then that changes our kinetic energy, or it changes our work. Now, in most of the examples that we had before, what we were doing is if we lost potential, we gained kinetic, or if we lost kinetic, we gained potential. But we said it also works with work. Well, in this case, it's going to work with work. So the part we don't care about is the potential. What's happening here is when he pulls the arrow back, he's doing work. Before he pulls the arrow back, the bow has no energy in it, and so there's nothing to get the arrow to be propelled forward. But when he pulls the thing back, he has to apply a force over a distance, so he's doing work. So he has a force and a distance that he pulls back with. Well, that stores up energy inside the bow in the form of potential energy, but when he releases it, that potential turns into the kinetic energy of the arrow. So mv squared over 2. So if we're interested in how fast the arrow comes out, we're looking at v. So if we're looking at this, then the 2 comes from the bottom on this side to the top on that side, and the m comes from the top to the bottom over on this side. And of course, to get rid of this, I will want to do that. After making it prettier, it looks like that. Now, remember, this is 2 times F times D. That's not FD squared. So we're going to just plug in my force. Clearly is going to be the newtons. The distance was, we pulled it back 0.65 meters. And this is times 2. And we divide by the mass of the arrow, which was 0.10 kilograms. Plugging that into the calculator correctly, we find out that the arrow comes flying out at 62 meters per second. Nice and fast. So now we have that speed. So the second question was asking, how far does the arrow travel until it hits the ground? Of course, it's going to come flying out of the bow, and it's going to travel in a parabolic trajectory until it hits the ground. So if it's traveling like this, we have to remember back to what we learned in Unit 5. And if we're looking for how far horizontally it goes, then that is, of course, VH times T. Well, a minute ago, we just found out how fast the arrow is coming out. That's 62. So that's this part. All we got to do is find out how long it takes the arrow to fall. The arrow is going to fall 1.5 meters. And of course, you remember, the time down equation was the square root of 2 dv over g. So here we're going to have 2 times how far does it fall? 1.5 meters over g, and that equals 0.553 seconds. So in a little over half a second it falls down, and in that time it was going this far over, so this was what we were missing here. 0.553 seconds means it travels a total of 34 meters before it hits the ground. And that's it. Nice and easy.